Okay, here we are at lesson 10. We're going to go back and take a look at proportional relationships and take more of a critical look as it applies to distance, rate, and time. So example 1 on your worksheet. Consider the word problem. We can do several things to answer this problem, but let's begin to organize our work using a table for time and distance. How many miles would Paul be able to walk in 50 minutes? And explain. Well, Paul could walk 4 miles in 50 minutes because 50 minutes is twice the time we were given, so we can calculate twice the distance, which is 4. So how many miles would Paul be able to walk in 75 minutes? And explain, similar to what you explained above. Well, Paul could walk 6 miles in 75 minutes because 75 minutes is 3 times the number of minutes we were given, so we can calculate 3 times the distance, which is 6. So how many miles would Paul be able to walk in 100 minutes? Well, he could walk 8 miles. And how many miles would he walk in 125 minutes? He could walk 10 miles. So our table should look something similar to this. How can we determine the number of miles Paul could walk in 137.5 minutes? Well, since the relationship between the distance Paul walks and the time it takes him to walk that distance is proportional, we let y represent the distance Paul walks in 137.5 minutes and write 25 over 2, which is 25 minutes to walk 2 miles, is equal to 137.5 minutes to walk y miles. And then solving our equation, we would end up that y equals 11. Therefore, Paul can walk 11 miles in 137.5 minutes. So how many miles y can Paul walk in x minutes? So we know for a fact that Paul can walk 2 miles in 25 minutes, so we can write the ratio 25 over 2 as we did with the proportion. We can write another ratio for the number of miles y Paul walks in x minutes, which would be x over y. For the same reason we could write the proportion before, we can write one now with these two ratios. So 25 over 2 is equal to x over y. Does this remind you of something we've done recently? Explain. Well, this is a linear equation in disguise. All we need to do is multiply each numerator by the other fraction's denominator, then we will have a linear equation. So we would have 25y equals 2x. Recall our original question, how many miles y can Paul walk in x minutes? We need to solve this equation for y. So that means we would divide both sides by y, and y would equal 2/25 x, or if we want a decimal, y is equal to 8/100 times x. So Paul can walk y miles in 8/100 x minutes. This equation will allow us to answer all kinds of questions about Paul with respect to any given number of miles or minutes. So let's go back to the table and look for y equals 8/100 x, or its equivalent, y is equal to 2/25 x there. What do you notice? Well, the fraction 2/25 came from the first row in the table. It is the distance traveled divided by the time it took to travel that distance. It is also between each row of the table. For example, the difference between 4 miles and 2 miles is 2, and the difference between the associated times 50 and 25 is 25. The pattern repeats throughout the table. So if you notice that every time we move to the next row we add 25, and every time we move to the next row here we add 2, which is again repeated addition or multiplication. So remember, we have done this work before, specifically finding a unit rate for a proportional relationship. The unit rate found in the table is exactly the same as the unit rate found using the proportion, and that the unit rate is the rate at which Paul walks. So let's look at another problem where only a table is provided. You'll need to copy this either on the worksheet or in your journal. So once you're done copying this table, go ahead and continue the video. Okay, with our table, we want to know how many miles y can be traveled in any number of hours x. Using our previous work, what should we do? Well, we can write and solve a proportion that contains both x and y, or use the table to help us determine the unit rate. So how many miles y can be traveled in any number of hours x? Well, if we go by the first row, it's 123 miles in 3 hours. Then that would be y is equal or over x. So therefore 123x is equal to 3y using our cross multiplication. And then to solve for y, we would do 123 divided by 3 times x, which simplified is 41. So what does the equation 41x equals y mean? It means that the distance traveled y is equal to the rate of 41 multiplied by the number of hours traveled at that rate. All right, let's take a look at example 2 in your journal. The point of this problem is to make clear that we must assume constant rate in order to write linear equations in 2 variables and to use those equations to answer questions about distance, time, and rate. Consider the following word problem. You might need to write this down. Alexa walked from Chase Field on 7th Street to Patriot Square on 1st Avenue. The total distance traveled was 1.1 miles. It took Alexa 25 minutes to make the walk. How many miles did she walk in the first 10 minutes? Well, she walked 44/100ths of a mile. You probably wrote a proportion to solve the problem. The next part of this discussion will get us to think about what is meant by constant speed, or rather, the lack of it. Are you sure about your answer? How often do you walk at a constant speed? Notice the problem did not even mention that she was walking at the same rate throughout the entire miles. What if you have more information about her walk? Well, Alexa walked from Chase Field along Jefferson Street to an ATM machine 3/10 of a mile away in 8 minutes. It took her 2 minutes to get some money out of the machine. Now, do you think your answer is still correct? Probably not, since now we know that she had to stop at the ATM. So let's continue with Alexa's walk. She reached 5th Street in 13 minutes after she left Chase Field, a distance of 6/10 of a mile. There she met her friend Karen, with whom she talked for 2 minutes. After leaving her friend, she finally got to Patriot Square 25 minutes after her walk began. Isn't this a more realistic situation than believing that she walked the exact same speed throughout the entire trip? What other events typically occur during walks in the city? Well, you could be stopping at lights at crosswalks. There might be traffic you might have to wait for. Maybe you tripped or fell, or maybe you had to run an extra errand. So this is precisely the reason we need to take a critical look at what we call proportional relationships and constant speed in general. The following table shows an accurate picture of Alexa's walk. You might want to write this down too. So after you've copied it down, continue the video. So with this information, we can answer the question. Alexa walked exactly 3/10 of a mile in 10 minutes. Now that we have an idea of what could go wrong when we assume a person walks at a constant rate, or that a proportion can give us the correct answer all of the time, let's define what is called average speed. Suppose a person walks a distance of d miles in a given time interval, t, which we'll put in minutes for now. Then the average speed is the given time interval of d over t in miles per minute. With this definition, we can calculate Alexa's average speed. The distance that Alexa traveled divided by the time interval she walked is 1.1 miles over 25 miles per minute. So if we assume that someone can actually walk at the same average speed over any time interval, then we say that the person is walking at a constant speed. Suppose the average speed of a person is the same constant c for any given time interval. Then we say that person is walking at a constant speed. If the original problem included information specifying constant speed, then we could write the following. Alexa's average speed for 25 minutes is 1.1 divided by 25. So let y represent the distance Alexa walked in 10 minutes. Then her average speed for 10 minutes is y divided by 10. Since Alexa is walking at a constant speed of c miles per minute, then we know that 1.1 divided by 25 is equal to c, and we know that y divided by 10 is equal to c. Since both fractions are equal to c, then we can write, using substitution, that 1.1 divided by 25 is equal to y divided by 10. With the assumption of constant speed, we now have a proportional relationship, which would make the answer you came up with in the beginning correct. So we can go one step further and write a statement in general. If Alexa walks y miles in x minutes, then y divided by x is equal to c, and 1.1 divided by 25 is equal to y divided by x. To find out how many miles y Alexa walked in x minutes, we solve the equation for y. And we would end up with y is equal to 1.1 divided by 25 times x. So where the last equation is an example of a linear equation in two variables, x and y. So with this general equation, we can find the distance y Alexa walks in any given time, x. Since we have more information about Alexa's walk, that is, where and when she stopped, we know that this equation cannot accurately predict the distance she walked after a certain number of minutes. To do so requires us to assume that she walks at a constant rate. This is an assumption we can generally take for granted when solving problems about rate. Alright, let's try exercises 1 and 2. Go ahead and complete exercise 1 and 2 and continue the video to check your answers. Alright, here is the answers to 1A, B, and C. Again, if you have any questions about how they've set up the problem, please make a note and bring it to class. Okay, continuing on with D, 2A, and 2B. And last, finishing up with C and D. All right. Let's go ahead and continue our discussion in our journal. Consider the problem. Dave lives 15 miles from town A. He is driving at a constant speed of 50 miles per hour from his home away from, or in the opposite direction of, the town. How far away is Dave from the town after X hours of driving? Well, since we know that he is driving at a constant speed of 50 miles per hour, then we need to determine the distance he travels over a time interval. If we say that Dave is Y miles from town A after driving X hours, how can we express the actual number of miles that Dave traveled? Well, Dave is 15 miles away from town A to begin with, so the total number of miles Dave travels is Y minus 15. If Dave's average speed is X hours, is Y minus 15 divided by X, which is equal to the constant, for example, his constant speed, then we have the equation Y minus 15 over X is equal to 50. We want to know how many miles Dave is from town A, Y, after driving for X hours. Solve this equation for Y. So again, multiplying both sides by X to get rid of the denominator here gives us Y minus 15 equals 50X. Add 15 to both sides, and we finish up with Y is equal to 50X plus 15. So with this equation, Y equals 50 times X plus 15, we can find the distance Dave is from town A for any given time X. How far away is Dave from town A after 1 hour? Well, if X equals 1, then Y would equal 65. So Dave is 65 miles away from town A after 1 hour. All right, complete exercise 3 on your worksheet based on the last example, then continue the video to check your answer. All right, using our table, your equation should be written in the middle column and your answers in the right column. All right, average speed is found by taking the total distance traveled in a given time interval divided by the time interval. If Y is the total distance traveled in a given time interval, X, then Y over X is the average speed. If we assume the same average speed over any time interval, then we have constant speed, which can then be used to express a linear equation in two variables relating distance and time. If Y over X is equal to C, where C is a constant, then you have constant speed. All right, we'll see you in class.